Welcome to ClearObject. At ClearObject, we're very proud to be a Google Cloud Premier partner and to use our experience in custom GenAI and Vision AI solutions to help you drive more business and close more deals. Based in Indiana, ClearObject has happy customers across North America, Europe, and multiple industries. Our customers include multinational manufacturing leaders, well-known innovative retail brands, large financial services institutions, utilities and infrastructure, and more. At ClearObject, we help organizations unleash their full potential by transforming data into valuable outcomes. We recently partnered with Google Cloud to install a permanent display in Chicago's MXD, Manufacturing and Digital Center. It shows how generative AI can interpret visual data, provide actionable insights, and encourage natural language interfaces to help operators streamline their business processes. At ClearObject, AI isn't theoretical. This is not vaporware. Our experts are experienced in taking solutions from the ideation state to proof of concept to scalable launch built on Google Cloud tools. Our integration processes ensure a smooth transition into the world of AI with minimal disruption to existing operations. ClearObject can provide ongoing support and maintenance for your customers, keeping the door open for future business. We're ready to help you accelerate your deals. To help you understand, here's a demo of a recent solution we built for a multi-billion-dollar financial services institution.
Hi, I'm Jason Legenis, and I am a product manager at ClearObject. We're a Google Cloud Premier partner, and we have partnered with Google to provide both GenAI services as well as tooling that deploys easily onto Google Cloud. I'm going to walk you through our high-level approach and what that tooling looks like, and we'll finish with a demo. So what are the main challenges that we focus on when we talk about enterprise GenAI solutions? So we do dig in really deep into the accuracy problem. So large language models at the end of the day are just prediction machines trying to figure out what is a likely next word based on a massive training set. So we need to ground it in the truth. We also need to ground it in data that wasn't available in the data set that is relevant to your organization. So we dig in deep on those areas. It's also important to be able to develop and iterate on these solutions pretty quickly. Something we have worked on is a low-code application to make it easier to test out new flows, new agent configurations, new workflow configurations, and also just being able to deploy that architecture very quickly into your Google Cloud environment. Something else that's very important, which I just noted on the accuracy side, is how do we incorporate your data? So that's cool that you can ask questions about famous movie stars or who won the World Series and things like that. But how do you ask questions about things that are in your databases that the model would have never seen? We do focus a lot into how do we ingest data relative to, say, vector databases for retrieval augmented generation techniques. Just having those connectors available and also being able to use those workflows we just talked about to add in some extra guardrails and instructions during ingestion and runtime to best utilize that data. Something else that we do focus a lot on, something that is a big challenge right now, is just the interpretability of the answer that you're getting. So you need to build trust and to say, I actually trust what this chatbot or this system is giving back to me. And so we focus on looking at how do we give context to what was the information that was utilized and sent to the model to ground it. What happened in the vector match process? Did something break there? As well as just kind of digging into being able to see what is the reference material, actually see the PDFs, load them up. All of that can build trust in our solution by being able to see what's going on there. And so we've spent a lot of time building in these sorts of features into our tooling. Just to talk about our tooling a little bit, we've developed something called GenAI Builder. So we believe this is built with best-of-breed GenAI tooling from Google Cloud. This also includes, as mentioned, a low-code interface. We have Google Auth built in. Very easy to use, and a number of ways to integrate your data. And so again, all of this is very easily deployed on Google Cloud. We are using a number of services from Google, a lot of things from Vertex AI, as well as just standard things like storage, compute, and Firebase, for instance, for deploying the app. So what are the key differentiators that we're focused on? We do want to enable users to make generative AI agents and workflows quickly and iteratively to test the efficacy to make accurate solutions for the enterprise. Again, our architecture is very easily deployable on GCP. And beyond just the tooling and the expertise we provide, we have actual services to go along with it. We can build these solutions for you. And we also have some novel techniques to how we do advanced retrieval augmented generation with something we call microprompting. All right, so with that, I am going to just give a quick overview on some of the architecture and key concepts in this space to give some context to how our platform works. Hi, so I'm going to quickly go through and walk through the architecture for GenAI Builder here. I just want to note at the top, we do have things a little bit color-coded. So users are in purple, we have the enterprise applications in orange, which is how do we interface with the app. The gray components are showing these are the components of the GenAI Builder. And then in green, we're going to show, these are the things that are kind of unique to your organization, be that data and configuration information. So we do have an application that's deployed on Firebase. Google Auth integration comes built in. And this is where data scientists and cloud engineers can work in a low-code platform to design and build new workflows and agents. And you can see here, we're able to pull in data through a data ingestion processing service, pre-processing and chunking and embedding service into a vector database. We support many different types of vector databases. Vertex AI has a vector database available. And then we also have embedding models from Vertex AI that will be used, at runtime to translate questions, and then do the retrieval augmented generation approach, pull the data back in and give you a response. So just want to note here something at the top right. So we do have the ability to integrate with existing interfaces. So from the runtime Docker container, which we currently deploy to Cloud Run, or if you have your own Firebase app that you want to integrate with, just want to note you can very easily integrate those types of services with this runtime. All right, next we're going to look at some of the more kind of concepts. What exactly is in GenAI Builder, not architecturally, but functionally? Just some things to note here. So we do have the core interface that a developer can work with. We do also have some back-end services and libraries that if you don't want to work through the interface, you can just work directly with this back-end. The idea here is we're going to, we can take in a lot of different external data sets, be that just raw storage somewhere. If you have your own enterprise data systems, maybe you want to integrate with the job scheduler or something like that. That can all be done with this back-end service. And then within that service, we have a lot of different configuration things that are stored. So you're going to have different agent configurations. This could include things like what large language models the agent going to use, what are some in-context learning things that are utilized, what data does that agent have access to. We also have configurations for workflows. So you can set up multi-step workflows that could do things like pull in data, use an agent to make some changes to that data. Maybe it's multiple agents, maybe you're adding guardrails. You could even re-embed that data, put it back into a vector database, or push that data out to some other database like BigQuery. So from there, you're going to have a library of these different agent configurations for both agents and workflows. And just to kind of make that a little bit more real, to show how these two things can work together. So at the bottom left here, we're going to show if I have a loan policy query runtime workflow. This is what's going to happen at runtime. At the top right, you can see how do we initially store the loan policy documents. And so one workflow is used to ingest data. So say, we'll get HTML data from raw storage. We're going to use a few different agents or a couple different agents to extract the data, to summarize the data, create grounding statements, embed the data back into the vector DB, and then make that data available in Firebase as well. And then at runtime, someone may ask a question of like, hey, I'm in this situation. Would I be approved for an exception for this type of loan policy? What will happen is we'll reference a different workflow, some different agents at runtime. We will do RAG at runtime based on the data that was pulled in from the other workflow. We'll have another agent, produce the final response and put that into the output. So I'm going to give you a very quick preview of ClearObject's GenAI Builder tool. And this first main chat feature to note is where we can select different agents to interact with. And we also have some extra tooling specifically looking for folks that are building enterprise-based applications. We really need to dig into the back end of exactly what's going on. So on the right here, you can see we have this backend query mode where you can see the user query. You can see some of the filters that have been applied in the backend to the data that's available to RAG. You can see the different sections of RAG that have been pulled in. And then you can really just kind of dig in to see, is there a scoring issue with the matching? Are we not getting the right data? So you can really kind of dig into what's going on with your query. At the same time, you can just see the reference data in whole, as opposed to just, the different components that go into the context. So, if you do reference some sort of guide or something and answering a question, that will all be visible here. Do you want to quickly touch on the workflow designer? So this is where you can really go deep into making multi-step, multi-agent workflows. So you can see here, we have a financial table embeddings approach where we could extract data from the table, extract metadata from around the table in the report itself. You can do things like adding instructions and guardrails, say add QA steps, and then even do the embeddings and import the data or export to another system from here. This is really helpful for trying out new studies, building production level pipelines, or if you see some new prompting technique you want to test, you can do all that here in the workflow. And just as a quick little overview on the agent designer, we can come in here and set up the different in context prefaces, notes. You can do few-shot prompting with some question and answer examples. You can choose which embedding model to use, which large language model to use. All of that can be configured here in the agent profile tool. All right, so with that, we are going to move on and talk about a specific GenAI use case. And we're going to show you a quick demo. So the use case we're going to be talking about today is a mortgage GenAI assistant. So in the mortgage industry today, users have, especially loan officers, don't always have all of the context they need. They don't know everything about all of the lengthy financial policies, say specific to a state or at the federal level. And so often there's a support team. You have a loan policy specialist that's going to be helping support that officer. That may take a lot of time to get an answer back. Even for those policy experts, it's hard to keep on top of all of the new documentation coming in. So what we've been working on with one customer is making an automatic assistant that can generate answers much faster. Sometimes we do have a human in the loop, like a loan policy specialist, to vet the answer, which is a really important thing right now, while we're making sure we get accurate results. But we can get much quicker answers back to a loan officer. So what we're going to demonstrate briefly here is a use case where a loan officer may have some questions about, hey, what does a typical mortgage look like in this state or in this region? And we really want to also show off some of the multimodal capabilities that we're building into GenAI Builder, such as the ability to ask questions of charts and maps and things. So with that, I'm going to hand it off to our lead GenAI data scientist, Noah, to do a quick demo. Thank you very much.
Hi there, I'm Noah Reese, data scientist at ClearObject, here today to show off the capabilities of our core multimodal RAG library, which is powered by Google's Gemini Pro Vision model. We're still adding some UI UX support for these features in our main GenAI builder, so I'll be running things from a notebook today. The use case I'll be showing for it is multi-turn chat with multimodal RAG support, which we're building for target clients in the financial services industry. This demo in particular is geared more toward the home loan and mortgage domain. So for context, we've pre-seeded our vector database with mortgage information from the web in both image and text modes. There's a lot of plots including some rather data-dense ones. So let's see how the system handles queries with follow-ups. To start things off, I'm just going to ask something of an open-ended question. According to our latest report, what is a common monthly mortgage amount for someone living in the Northeast? And I'll fix this typo real quick. All right. So we've pre-seeded our vector database with a fair amount of US-based information. So Northeast does imply the Northeast of the United States. All right, so we've got our query here. Here's the response as well as the reference images that were pulled from the RAG system. So just to skim this, I can see you're looking for a map. You're looking at a map of the United States shows the median home price by state. Median home price in the Northeast is $439,000. Current 30-year mortgage rate is 6.71. That seems correct based on the plot it pulled as well. To calculate a monthly mortgage amount, we need to know the loan amount and the interest rate. So it does some math here, and it's running through. So a typical monthly mortgage amount is about $1,900 or so. So it's got fairly detailed analysis in this case. So it's pulled in these images. It's done some synthesis on those according to the user's query and some tooling under the hood. We can see the image references here. So we've got the actual links as well and the images that were pulled from our multimodal RAG. So next, I'm just going to ask a follow-up question, something that would reasonably use knowledge from the last question. In this case, all right, so it's given me a number for a mortgage. So what percentage of a typical household income, how about monthly income would that represent? So it's doing its thinking, it's pulling RAG, it's using the conversation history to come up with a better answer. So we've got the image that it pulled is the median family income in the Northeast is $104,000. Again, it knows we're talking about the Northeast already based on the conversation history. Qualifying income is $120,000. So the monthly mortgage amount of $1,900 roughly would represent 18.35% of the median family income. So it's provided statistics for both. It also did pull an image from the National Association of Realtors. So that is fantastic. It's been doing great. The other component I'd like to show is single shot prompting, which we use on the ingestion side, particularly for metadata generation. So let's say, for example, we have an image. In this case, I'm just going to show the last one. Okay, so it's this bar chart. And we want to extract additional information, for example, metadata that we can associate with embeddings, maybe the image itself. A little into the weeds, but this is an important use case. So I'm going to ask it to extract a markdown table from this plot, create 2 columns for the income metrics, and a row for each region. All right, so it's going to run through. It's going to try its best. Let's see how well it does. Again, this is more of a single shot approach. So US, so it's done the thing we've asked, 3 columns, right? We've got the median family income, qualifying income, and region. It's got a row for each. And again, these 2 data-rich columns are the 2 columns we requested for the income metrics. So US 91-104 does a pretty good job reading that off a relatively complex chart. Let's just look at like the West 100 and 159. So there you go. Hopefully you enjoyed this demo. We're really looking forward to building more with Gemini. It's really fantastic tooling for our platform. So yeah, thank you very much.